Before an AI can understand your message, it must first break the text into smaller pieces, called tokens. This process is known as tokenization. A token can be a word, part of a word, a number, or even a punctuation mark. The AI processes these tokens, one by one, instead of reading the entire sentence at once. Tokenization is the first step that helps large language models understand and generate human-like language. When you type a prompt, the AI does not read it like a human. Instead, it first breaks the sentence into small pieces called tokens. These tokens are then sent into the AI model, one by one. The model analyzes each token, understands the context, and predicts what should come next. This step-by-step process allows large language models to understand language and generate accurate responses. So, what exactly is a token? A token is a small piece of text that an AI model uses to understand language. It can be a complete word, part of a word, a number, or even a punctuation mark. Instead of reading an entire sentence at once, the AI processes one token, then the next, until it understands the full meaning. Tokens are the basic building blocks of every conversation with an AI. Not every token is a complete word. A token can represent a full word, part of a word, a number, or even punctuation. For example, symbols like @ numbers like 45, and punctuation such as comma or exclamation marks are all treated as tokens. This flexible token system helps large language models understand many different types of information accurately and efficiently. Let's see how tokenization works. First, you type a sentence. Next, the tokenizer breaks it into smaller tokens. These tokens are then sent to the AI model, one by one. The model analyzes each token, understands the context, and predicts the next one. By repeating this process, the AI builds a complete, natural response. Everything begins with tokenization. Let's look at a simple example. The sentence is, "I love AI." The AI breaks it into 4 tokens. I love AI, and the period. Each token is processed, one at a time. Even a punctuation mark is treated as a token. This is how large language models understand every sentence, step by step. Now, let's look at another example. The sentence is, ChatGPT is amazing. Depending on the tokenizer, ChatGPT may be split into 2 tokens, Chat and GPT. The remaining parts is amazing, and the exclamation mark become separate tokens. This shows that one word does not always equal one token. The way text is split depends on the tokenizer used by the AI model. Tokens are not only words. Numbers are also converted into tokens. For example, in the sentence, "I have 25 books." The AI identifies, "I have 25 books," in the period as separate tokens. This allows the model to understand text, numbers, and symbols together when generating accurate responses. Tokens are not just used for normal text. Programming code is also broken into tokens. For example, in console.writeLine, hello, the AI separates console, the dot, writeLine, the parentheses, the quotation marks, hello, and the semicolon into individual tokens. By understanding code, one token at a time, large language models can explain, write, and even debug programs accurately. Here's what happens behind the scenes. First, your input is sent to a tokenizer. The tokenizer breaks the text into smaller tokens. These tokens are then passed to the AI model, one by one. The model analyzes each token, understands the context, and predicts the next token. By repeating this process thousands of times every second, the AI generates a complete, natural response. The AI does not generate an entire sentence all at once. Instead, it predicts one token at a time. After generating one token, it uses that token to predict the next one. This process continues, step by step, until the complete response is finished. Although it happens incredibly fast, every response from a large language model is built one token at a time. Let's see how an AI generates a response. It starts with the first token, then it predicts the next token. For example, the, then capital, then of, then France, then is, and finally, Paris. Each new token is predicted using the tokens that came before it. This is how large language models Build complete sentences, one token at a time. Every large language model has something called a context window. A context window is the maximum amount of information the AI can remember during a conversation. It includes your current prompt, previous messages, uploaded documents, and even the AI's earlier responses. A larger context window allows the model to keep track of more information and produce better, more consistent answers over longer conversations. Not all AI models have the same context window. A small context window can remember only a limited amount of information. As the conversation gets longer, older details may be forgotten. A large context window can hold much more information at the same time. This allows the AI to remember longer conversations, understand larger documents, and provide more accurate and consistent responses. Large language model APIs measure usage by counting tokens. There are two types. Input tokens are the tokens in your prompt. Output tokens are the tokens generated in the AI's response. The more input and output tokens you use, the more processing the AI performs. That's why understanding tokens helps you manage API costs, estimate response length, and build more efficient AI applications. Let's understand the difference between input tokens and output tokens. Input tokens are the words, numbers, and symbols that you send to the AI. Output tokens are the tokens the AI generates in its response. For example, if you ask a short question, but the AI gives a long explanation, the number of output tokens will be much higher. Both input and output tokens are counted when using large language model APIs. Here's a real-world example. Suppose you ask, explain binary numbers. This question becomes the input tokens. The AI processes those tokens, understands your request, and begins generating new tokens. Those new tokens become the output. For example, binary numbers use only 0 and 1. The number 5 is written as 101. This entire explanation is made up of output tokens. Every conversation with an AI follows this same process. Input tokens go in, and output tokens come back as the response. Let's clear up a few common misconceptions about tokens. First, one word does not always equal one token. Some words can be split into multiple tokens. Second, tokens are not only used for text. Numbers, punctuation, programming code, and other types of data are also processed as tokens. And finally, the AI does not write an entire paragraph instantly. Instead, it predicts one token at a time extremely quickly. Understanding these facts helps you better understand how large language models really work. Understanding tokens is very important for developers building AI applications. It helps you write better prompts that produce more accurate responses. It also helps you understand API costs because usage is measured in tokens. Knowing how tokens work allows you to estimate response length and stay within context window limits. Whether you're using ChatGPT, Gemini, or another large language model, a good understanding of tokens will help you build faster, smarter, and more efficient AI applications. Let's summarize what we've learned. A token is a small unit of information that an AI model processes. Tokens can represent words, parts of words, numbers, punctuation, and even programming code. They also determine the model's context window and API usage. By understanding tokens, you can write better prompts, reduce API costs, and build more efficient AI applications. Mastering tokens is one of the first steps to becoming an effective AI developer.